Have you ever thought about where humans are going to go after Earth? It's not ideal for us to cram all of humanity onto some spacecraft that is perpetually coasting through the cosmos. We would be better off finding a planet, and while astronomers have found potentially Earth-like planets, they're all very far away. Believe it or not, the best candidate we have is right here in our own solar system. I'm talking, of course, about Mars. But Mars isn't currently suitable for life, so we need to terraform the red planet. This is easier said than done, so let's take a look at what kind of technology we would need and how long it would take to make this planet a place we could call home. As of today, the red planet is not habitable. For starters, the temperatures on Mars can get as low as -55 degrees Celsius. That's a bit too cold for us, and even if it weren't, Mars' atmosphere lacks sufficient air pressure. It also contains 96% carbon dioxide, which is way too much for humans to breathe. We humans are pretty fragile when it comes to atmosphere. If the pressure is too high or too low, we die. If we don't get enough oxygen, we die. If the radiation dose gets too high, you guessed it, we die. So, it stands to reason that our first priority in terraforming Mars is to raise the temperature and rebuild its atmosphere. Lucky for us, CO2 is quite abundant in Martian rocks and in its polar ice caps. Once the CO2 is released into the atmosphere, it could help trap heat just like it does here on Earth. This could trigger a greenhouse effect, raising the temperature and melting Mars's ice, giving the red planet back its liquid water in the form of flowing rivers and oceans. All of this is possible, at least theoretically. It should come as no surprise to anyone that Elon Musk has his own ideas on how to go about doing this, and that his ideas may sound a bit out of left field. According to Elon Musk, the quickest way forward is to nuke the Martian poles. Detonating thermonuclear weapons over the poles could provide the nudge that's needed to perhaps trigger a runaway greenhouse effect on Mars. Heat released from the bombs would melt the CO2 frozen at the poles. This could, in theory, help immediately thicken Mars's thin atmosphere. As sunlight is trapped by the CO2, the temperatures would rise, more ice would melt, and so on. There are other ways to raise the greenhouse gas levels. For instance, building large orbital mirrors placed near the poles that will reflect sunlight and heat the Martian surface. These mirrors would have a diameter of 250 kilometers or 155 miles and cover an area larger than Lake Michigan. This will trigger a cycle of warming by causing the polar ice caps to melt and release their CO2 gas, which would thicken the atmosphere. Scientists have also proposed a powerful enough magnetic shield launched into space that could serve as a replacement for Mars's own lost magnetosphere. This could protect Mars from solar winds and give the planet a chance to naturally restore its own atmosphere. Over millions of years, as the atmosphere becomes thicker, Mars's climate would become warmer. If nuking the red planet, building magnetic shields, and sending mirrors 250 kilometers in diameter into space sound a bit too far out of the reach of reality, the best option might be to simply engineer microorganisms to do all the terraforming of Mars for us. It took the Earth billions of years to transform into a planet on which plants and animals could flourish. Assuming we do come up with a solid plan to make the red planet habitable, terraforming Mars into an Earth-like habitat would take several millennia. So, we should really focus a good deal of our efforts into figuring out how to make the home we have right now last as long as possible.